Hello everyone, welcome back. In this video lecture, we'll be learning or we'll be entering into a new chapter of Spark tutorial series, which is Spark Streaming. Whenever we talk about data processing, there are two different use cases in processing the data. The first use case would be where the data is static and the processing is done on entire data as one unit of work, or by dividing it into smaller batches. While processing that small batches of data, the underlying data doesn't change, or new data will not be added to the underlying data. This kind of processing is called as a batch processing. If you observe till now, whatever we have learned in the Spark with Spark SQL or RDDs or Spark Core or whatever, we have been working on a batch processing because we are working on a data set which is a static, where data is not getting changed when the processing is in progress, or data is not added, new data is not added to the file, or when the processing is in progress, right? So whatever we have learned or whatever we have done till now is nothing but Spark batch processing. And the second use case, or second type of use case, is where the data is getting generated like a stream, and the processing is done as and when the data is generated. This kind of processing is called stream processing. Starting from this video of Spark tutorial, we'll be learning stream processing with Apache Spark. We'll cover data stream processing, micro batch processing, window data processing, and window data processing, and other options which are there within it. And we'll also work with the integration of Spark streaming with Apache Kafka as well. And we'll run an application with this integration as well, and we'll see how Spark streaming works with Apache Kafka. Spark Streaming majorly has two different APIs available. One is DStream API, and the other one is structured streaming. Starting from Spark 2 and above, this structured streaming has been implemented, where the processing of data is done on top of data frames or data sets. Whereas a DStream, the processing is done on top of RDDs. This is the main difference between the DStreams as well as this structured processing. So in this video, we'll start learning about DStream API. That means we'll be working with the DStream API, where underlying data would be stored in the form of RDDs, and we'll work with that kind of stream processing. So let's create a Spark job or Spark job file. Let me create a mail. Firstly, to work with the Spark streaming, first thing we have to have is Spark configuration. So first, let's create the Spark conf, and we can set master, and I can first initially I would like to run this application from IDE, and later I'll show you how to run the same IDE in the form of jar file in GCP cluster as well. So for initial demo, I'll use the master as local and try to run it in the IDE. Sorry, and I'll set the application as application name as Spark DStream example. Now I have my Spark config ready. To create a Spark streaming context, which usually defined as SSC, I can define this with something like Spark streaming context, and I can pass the Spark configuration what I have created, and the time duration in which my batch processing has to be done. Let me give this as 5 seconds. See, when data sources generate data like a stream, where this stream has to be processed in real time, right? That's where this stream processing come into picture. When we say real time processing, right, the meaning of real time processing changes from use case to use case. The main parameter that defines what is meant by real time for a given use case is how soon the data is the data that is ingested, or the frequent interval in which all the ingested data since the last time interval needs to be processed. To put it in a more simpler way, it all depends on how fast the data needs to be processed. Whenever we say how fast, there comes the term as time, right? The faster the processing, right? How do you measure the processing time is faster or slower? It depends on the time, right? So how fast you want to complete the data, or how fast you want to process this real-time data, depends on the time. So that's where this time interval, or whatever we give as a parameter to the Spark streaming, comes into picture. When processing stream data in regular intervals, data is collected from beginning of this time interval to the end of the time interval. For example, suppose if I start this application right now and have given the processing time as 5 seconds, the starting time would be 0th second, and it will wait for the 5 seconds time duration. 5 seconds is the end time interval, right? So this is one batch of data from 0th second till 5th second. Whatever data is generated within this 5 seconds, this data is this is just a micro batch, right? This is also just a batch of data, but instead of taking entire batch of data, like entire time interval of the data span, we'll be taking only micro batches of data, which is 5 seconds worth of data, right? This 5 seconds worth of data is processed by this Spark application, and it generates the result. Over a period of time, when you consider, right, the data processing is done on many micro batches by this streaming application, right? If I run this application for say 5 minutes, and per minute it will run 30 batches of data. For 5 minutes it runs into 30 into 5, 180 batches of data, right? So this is how it works. So here, right, whenever a batch of data is getting processed, the Spark application will have the track of only that, will have the information about that particular batch of data. For example, suppose I have processed my data from 5th second or 6th second till and 5 seconds span from 6th second, which is 10 or 11 seconds, right? So whatever data is there between this 5 seconds worth of time, only that data, only and Spark will have visibility to that particular data micro batch, right? It will not have visibility to the previous batches of data, that is 0th to 0th second to the 5th seconds, or 1st second to 5th second time interval, right? But there are use cases where you might need you might need to track whatever happened, or whatever data is ingested in our previous batch, or previous micro batches, or previous time intervals as well, right? For example, if you consider a fraud transaction in a retail banking or anything, where where a retail bank has a use case where it has to keep track of ATM withdrawals on the same ATM with the same card for the past 15-20 minutes. Suppose there are 10 or 20 transactions happening within this 15 minutes, then that might be a fraudulent transaction. This retail bank, might have to have the track of this past 15 or 20 minutes worth of transactions within the same ATM and with the same card, right? So that might come under a different batch, right? So these kind of transactions, or these kind of use cases, need to have the visibility of data in our previous micro batches, right? So in that cases, right, the streaming application, or the streaming framework, whichever is being used, should have the capability of handling this kind of scenario as well. Spark absolutely works with these kind of situations, and it provides both current batch data, and it also provides a peak to the previous batch, or a sliding window of time interval, so past 30 minutes or 15 minutes or something. So in that way, it supports these kind of fraudulent transaction use case as well. So Spark has capability of supporting these two use cases as well. So that's why it has become very popular in terms of stream processing in a big data environment. Right? Now I have created this Spark streaming context, and here I'm specifying to the streaming context that every 5 seconds you do the processing or do the transaction processing or on the data whatever we have received within that period, right? And so what kind of transactions I have to I can do that. You can do any kind of transactions that can be done with an RDD, right? So let me just create suppose it's just a basic word count example, or a hello world kind of example in the Spark streaming is like a word count over the network, right? So let's try to create that example, and later we'll see how to read it in the coming videos, right? We'll learn how to read a directory, and whatever new files are ingested into that directory, how to read those files and do the processing. We'll get into that scenario as well. As a first introduction to the Spark streaming, I'll just show you how this streaming works, and later we'll dive into those details. Right now, let's just read the Spark streaming context. Using the Spark streaming context, there is something called socket streaming, socket text streaming. That means it listens to a particular host. I'll try to listen to the local host, which is the current machine which I'm running on, and it can listen to a specific port as well. Suppose I would like to return listen to a port 9999. In this statement, what we are trying to tell Spark streaming context is to listen to this particular port number on this particular host, where you'll get a text stream of data. That's what we are telling now. So whatever data I'm getting right now over here is you can see here, it's a DStream of type string, right? It's a DStream of type string. So once I have a DStream, right? DStream is very similar to the RDD. DStream is nothing but discretized stream, and it is very similar to this RDD. Just like RDD, DStream is also immutable and distributed, and supports all Spark transformations and actions, right? And you can also consider that a DStream can consist of one or more RDDs, and whatever transformations we'll be applying, or whatever actions you'll be applying on top of this DStreams is almost like you're applying transformations and actions on top of an RDD. Now I have this DStreams. I'm just writing a word count example over the network. So what I have to do, I have this word now, and let me create words out of the lines, whatever I have created over there. And from lines, I'll do a flat map. Whatever line I'll get it, I'll just split that line with a space, and I'm getting number of words over here. Once I get the words, what I can do, I can create a pairs of words. So I can create pairs by words dot. By map function, I can do this pairs. Word implies word comma 1. Now I have the words. I can do the word counts by doing pairs dot. I can use the reduce by action, and I can do the sum of the words whatever I have created. Now once this word counts, what this is our motive, that's what I want to achieve, right? So whatever I'm getting over here is a string comma, it's a string comma integer. String is the word and the integer is the count on that particular word. And if I want to print the results, what I can do, I can just go ahead and do print. This is the main logic whatever I have written in these lines, right? Once your logic is written, you have to tell your Spark streaming to start its processing, right? So to do that, what I can do is ssc.start. There is a method called start, which lets your Spark streaming to start the stream processing. Once this stream processing is done, you'll have two options, whether you want to run this stream processing indefinitely or you want to run it for a specific period of time. Even that you have to specify. So I want to run it either await till termination, that means infinitely it will be running, or await termination or timeout. It will wait for a certain time, like 5 minutes or 10 minutes, depending on your use case. You can mention this much time you can run this streaming application, and then you can stop this application. And now I'll just run this application in an indefinite loop. And this is a basic coding of how one will start a Spark streaming session, and how we'll have to initialize a Spark streaming context and with the Spark configuration, and create a DStream and work on top of DStream. And whatever results we are getting from the DStream, I'm running that, or I'm printing that results onto the console. So so let me run this job in my IDE itself initially, and later we'll uh, try to run the same job in a GCP cluster, and we'll see how it works there. So when I'm trying to run from my local node, I would like to give only two cores. I don't want to give entire cores available in my machine, and so I've restricted it to two cores. And let me run my job. Now you can see that my Spark job is throwing errors, and if you observe, it is trying to listen to the particular port, which is localhost 9999, and there is no data that's getting generated on that particular port. That port is right now closed, right? So that's the reason it is throwing an error. So to overcome this, right, what you have to do, you can go to the terminal. If you are working on a Windows or Linux machine, if you are working on a Mac or a Linux machine, you can go to the terminal and you can run a command called nc-lk, and you can give a port whatever you are working on. I'm working on a port 9999, right? So this nc command will let you generate a data on a particular port. So here I'll be using a port 9999, which I have configured in my code, right? And let me run this. So as soon as I hit this, this command waits to read the data from the console, whatever we type in over there. So here you can see that the errors are gone, and it is waiting for, and it is printing something for every 5 seconds, right? So to do the word count or something, let me do this. Right, so every 5 seconds it is trying to do, right? So what I'll do, and have done some printing over there, and let's see after the 5th second what it will generate. And now you can see that it has generated with a spelling mistake, it is generating as a 4 words, and with proper spelling it has 8 words, right? You can also do something like this. Even this is also done, because we have done the logic to split the line with the spaces, right? So, and you can see, and later also it is able to split the data, or split the line whatever you have print, and it is working on. Right now, whatever the job, right, it runs indefinitely until we stop this application explicitly, and it keeps on listening to the particular port, and whatever we type over here, it will be trying to do the word count of that particular thing. And you can observe that it is currently working on a particular batch. That's what I was referring to, right? The Spark program will have the visibility to only this particular batch, and if you want the visibility to the previous batches, we have to use the sliding window operations, which are part of windowed operations, which I'll be covering in my coming videos, right? So currently, whatever the data processing is being done, it is being done only on one batch of 5 seconds time duration, and the statistics or the counts or whatever we have over there are only for this particular batch, right? So let me just stop this application, and let me try to build a jar and deploy it in my Spark GCP. I have already opened my Spark GCP console. There are two different sessions, or two different terminals I have opened my in my Spark GCP cluster, and let me clean the jar, clean and build the package. Once this package is done, we have to follow the same thing, like nc-lk, and we have to make sure we are listening to that particular port. And here I have mentioned this set master as local to here itself, so I don't have to mention this master, whether it is local or yarn or whatever in the Spark submit command. So even that is also fine. If you want to override or if you want to specify everything like Spark, yarn or client or anything, you can remove this when you're building the jar and you can deploy it. It is absolutely fine because I'll be running in the local mode. It's just not a resource intensive. It's just a demonstration of a Spark streaming, right? You don't have to have to run it in yarn client as well. So I have my jar ready. So let me upload the jar. Upload, and my jar file is this GCP 1, and now this upload is closed. To run this Spark job, Spark submit, and I can mention the master, but I already mentioned the master over here, so I am not mentioning that. But I'll be specifying my class where which one I have to run on. So this is a jar file, right? Now you can see the Spark job is started and it is waiting for input for that particular port. Now let me type in something about Apache Spark. See, you can see that even though I'm typing over here, it is not calculating anything over there because I haven't given enter, right? Only when I give the enter or return button, then only the stream will be sent this particular port. Right now I'm typing. So it is not. This is Apache Spark tutorial, right? Now I'll give enter, and now you can see this. It has picked up something, and it is trying to calculate the word count, and it is printing over there, right? This is pretty much it. It is straightforward execution, even in the local IDE or in the Spark cluster or anywhere. This is the same process, right? So that's it about this Spark streaming introduction, guys. And in the coming videos series, we'll learn about the structured streaming and windowed operations, and we'll also try to integrate Apache Spark with Kafka as well, right? So this is just an introduction to the Spark, and hope you like this video. If you are new to this channel, please do subscribe to the channel, and if you have liked this video, please do give a thumbs up. That's it for this video lecture, guys, and see you in the next video. Bye, guys.